Assalamualaikum. My name is Farah Irsalina binti Ishaq with my metric number 2020963619 and I am the first presenter.
My name is Muhammad Nazmi Irfan bin Muhammad Rizwan with my metric number 2020960977 and I will be the second presenter.
Hello everyone, my name is Ain Nadia binti Ismail. My metric number is 2020974441 and I am the presenter.
First of all, I will present about our abstract. Our study aims are first, we want to compare the efficiency score between the 14 states in Malaysia, and after that we will suggest the best water supply system to be set as benchmark for another state to improve their inefficiency. And the last one is providing a solution to improve the current efficiency for the inefficient DMU or states. Next is study goal, which we want to emphasize the efficiency score value of determining an efficient or inefficient water supply system. The score for efficient DMU is equal to 1, while the score for inefficient DMU is less than 1. Hence, from the score, the lacking area can be improved, while the best is set to be an example for others. Okay, the last part for abstract is methodology phases, where for this research we have 3 phases. The first phase is determine and compare between CCR model and BCC model. Then, the result from phase 1, which we choose only the result in BCC model for next phase. Why we choose only BCC model is because according to a research by Delnitz et al. 2018, the result for the study shows that BCC model is better than CCR model in comparing the efficiency score for each DMU. For our next phase is to identify and suggest the best water supply system using super efficiency model. Only the DMU with score 1, the result from BCC model 10 will rank in phase 2. The last phase is improvement solution, which the inefficient DMU have been provided by the solution for the water supply system to improve in the future. Okay, then I will proceed with the introduction of this study. Water supply system is defined as a system of engineered hydrologic and hydraulic elements that provide water supply. A good water supply system will ease the consumer for their daily life use. Our country, which is Malaysia, depends on water supply from reservoir. The data in 2018 that have been reported from National Water Commission in brackets fine show that 81.3%, which is the biggest percentage of the water supply, is come from river, and another 17.4% is from storage dam. These two are the most common use for water supply in Malaysia. The next part will be continued by another presenter.
Let's continue with the literature review. This study applies DAA model such as CCR, BCC, super efficiency, and SBM model, which are commonly used by researchers to measure the effectiveness and the efficiency score of water supply system. This is all the previous researcher that uses DAA model in measuring the efficiency of water supply system. Why in this study the utilization of input orientation for CCR, BCC and super efficiency model will be used? The first reason is to minimize the amount of input spent per output in unit, while the second reason is to provide service to a specific geographical area and numbers of consumers. And for SBM model, the utilization of non-oriented model will be used to minimize the input while maximize the output in order to improve the inefficiency of water supply system.
Okay, let's move on to the methodology and result.
Multiply inputs and output are used in order to determine and verify the best water supply system and to suggest the best improvement for water companies. The selection of input and output are based on the previous research. In this study, the operating expenditure, water production, and raw water will be used as input, while the non-revenue water, revenue, and pipeline will be used as output variable. In the methodology phases, it will be starting off by determining and comparing the efficiency score of 14 water supply systems by using CCR model and BCC model. Note, the value starting from 0 to 1 will indicate the efficiency score, where if the value is equal to 1, it is indicated as efficient. Based on the result of the CCR model, 7 DMUs out of 14 were considered as efficient DMUs, where all the inputs are utilized to produce an optimum output. Furthermore, the BCC model result stated that only 8 DMUs are efficient while the other 6 are inefficient. And not to mention, Sarawak is the most inefficient DMU out of all. Based on the result of the efficiency score for both CCR and BCC model, the BCC model will be chosen for the next phases because it has the highest number of efficient DMUs.
The next phase, which is phase 2, is to identify and suggest the best water supply system of 14 DMUs using super efficiency DAA model. For this phase, we use the DMU with efficiency score equal to 1 that have been obtained from BCC model. All the efficient DMUs were ranked to find the most efficient DMU. From the table here, there are 8 efficient DMU that have been identified, which are Labuan, Perlis, Johor, Terengganu, Pahang, Kelantan, Sabah and Perak. DMU with the highest efficiency score will be set as a benchmark for other DMUs. Labuan got the highest efficiency score, which is 3.307692, and the DMU with the lowest efficiency score is Perak, with score is 1.039748. DMU 4, which is Labuan, is chosen as the most efficient DMU to be set as a benchmark. That's all from me. Thank you.
Okay, next I will explain about phase 3, which involving SPM-DAA model. We use this model to improve the inefficient water supply system DMUs in Malaysia. From BCC model, we know that there are 6 inefficient DMUs and we improve these inefficient DMUs using SPM model. Inefficient DMUs here means that DMUs with efficient score that less than 1. These inefficient DMUs are evaluated to improve the inefficient value by reducing its input value and increasing its output value. Here, we have the result by using SPM model. We can see that DMU 7, which is Pulau Pinang, has the lowest value of efficiency score 0.5060130, followed by the others DMU. In this SPM model, output improvement must be made, and at the same time, we also need to reduce the data inputs. When we reduce the input operating expenditure, we can directly reduce the operating cost and operational capital of water supply system. At the same time, the water company can achieve high profit by increasing the data outputs. Alright, here we can see the table that shows the improvement of inputs and outputs needed for the DMUs to be efficient in order to improve the operational efficiency. For example, DMU 7, which is Pulau Pinang, there is a decreasing value in raw water, where the raw water is one of the data inputs. The value of raw water decreased from 1105 to 969, while the pipeline, which is one of the data outputs, increased from 4542 to 12501. Okay, next I will proceed to explain about conclusion and recommendation. So, as we know, DAA models were used in this research to evaluate the performance efficiency of water supply system in Malaysia. We use 4 DAA models, which are CCR model, BCC model, and super efficiency model with input orientation, and we use also SPM model with non-orientation. In phase 1, we determine and compare the efficiency score obtained from BCC model and CCR model, and the result is we choose BCC model. This is because BCC model show the highest number of efficient DMUs compared to CCR model. 8 efficient DMUs were obtained, and these efficient DMUs were ranked by using super efficiency model in phase 2. Super efficiency model were used to identify and suggest the best water supply system in Malaysia, and Labuan achieved the highest efficiency score with the value 3.3079,692. Meanwhile, the other 6 inefficient DMUs were obtained from ZC model, and these inefficient DMUs were used in SPM model, which is in phase 3 to improve the inefficient water supply system in Malaysia. Pulau Pinang got the lowest efficiency score with the value 0.506130. Therefore, the improvement must be made through proper management of each water supply system in Malaysia. These improvements are important to ensure that water supply system manage to reach an efficient and effective implementation for giving the best quality of water supply system in Malaysia. For recommendation, water companies should provide alternative water resources during maintenance, where this action disrupt the water supply to consumer. The alternative should be made to provide the best water services experiences to the consumers. Moreover, the alternative or new water resources also need to be made, as water companies do not want any water demand, plus consumers could enjoy high quality water supply without any issues in the future. Okay, so here is the last section for the study, which is references sources. Here is the list of the main references that we use in this research. The first one is National Water Services Commission, which is PAN. Next are Norbaisur et al. Papers, followed by Nariman and Azhar papers. The last one is the paper by Hardian et al. There are also another resources used in this research, but here is the most resources that we rely on to. Okay, so that's all from us in presenting our final year project, Performance Efficiency of Water Supply System in Malaysia using Data Implement Analysis Model.